Okay, here's our final solution stoichiometry example question, the limiting reactant problem. And I'm hoping that this will go over well. Limiting reactants was something that our students had a lot of difficulty on the unit test just passed. So hopefully this will give you some additional practice on the concept of limiting reactants. Okay, in one process for water purification, aluminum sulfate reacts with calcium hydroxide to form a precipitate of aluminum hydroxide. When that solid is suspended in the impure water, the bacteria and dirt particles stick to the precipitate as it's settling out of the solution. So the question here is to find the mass of aluminum hydroxide that precipitates when 20 milliliters of 0.015 moles per liter aqueous aluminum sulfate is mixed with 30 milliliters of 0.0185 moles per liter aqueous calcium hydroxide. Okay, and here's the equation to help us. Aluminum sulfate gets together with calcium hydroxide. As a result, one of the things it creates is aluminum hydroxide, and that's the solid. When it precipitates, it comes out of the solution, and it helps to take out some of the impurities in the water. Okay, let's go through our process one by one. It's going to be a little bit different now because this is a limiting reactant problem. Step one, we're going to find number of moles. We're going to have to find the number of moles of aluminum sulfate and of calcium hydroxide in this case. So let's start with the aluminum sulfate. Okay, number of moles is going to be equal to concentration times volume, of course. So the concentration for aluminum sulfate is 0.015 moles per liter. The volume is 20 milliliters. So let's take that down. Times a volume of 20 milliliters. Okay, and then times 1 liter per 1,000 milliliters. Should work out to the number of moles being 3 times 10 to the negative 4 moles. As for the calcium hydroxide, number of moles is going to be equal to concentration times volume. There's the concentration, 0.0185. There's the volume, 30 milliliters. Times 1 liter over 1,000 milliliters should give us a total of 5.55 times 10 to the negative 4 moles. Okay, we're not done trying to figure out which one of these reactants is the limiting reactant. We need to do some tests to figure that out. And the tests we do, if you recall, the easiest way of doing this so let's have aluminum sulfate over here, and on this side we'll do the calcium hydroxide. I'm going to, for aluminum sulfate, I'm going to divide my number of moles take that number of moles, divide it by the one that's being multiplied by aluminum sulfate in the equation. Okay, and that gives me just 3 times 10 to the negative 4. For calcium hydroxide, we have 5.55 times 10 to the negative 4 moles. Divide it by the coefficient for calcium hydroxide, that's going to be 3. And that works out to be 1.85 times 10 to the negative 4. Okay, comparing these two numbers, 3 times 10 to the negative 4, 1.85 times 10 to the negative 4. This one is clearly the smaller value, and therefore calcium hydroxide is the limiting reactant. Calcium hydroxide in this equation is going to run out of moles of material before aluminum sulfate will run out of moles of material. So we go forward with the calcium hydroxide using stoichiometry. Okay, and what we're trying to find, what the question is asking us for, is find the mass of aluminum hydroxide. So carrying on with stoichiometry, here's what we're trying to find. Aluminum hydroxide. What is the mass of aluminum hydroxide? So our next step is to find the number of moles of aluminum hydroxide which will be yielded in this reaction. So step 2 of our stoichiometry process is going to be finding the number of moles of aluminum hydroxide. Okay, and we're going to use the number of calcium hydroxide moles that we have. So it's 5.55 times 10 to the negative 4. And multiply that by the molar ratio of aluminum hydroxide to calcium hydroxide. So it's going to be 2 over 3. Okay, and that's going to give us 3.7 times 10 to the negative 4 moles aluminum hydroxide. And so therefore, step 3, give them what they're asking us for, the mass of aluminum hydroxide will be number of moles times the molar mass of aluminum hydroxide. So that will be aluminum plus, that's our oxygen, plus there's our hydrogen mass. Put all those things together and you should end up with 2.89 times 10 to the negative 1 grams, 0.289 grams of aluminum hydroxide. Okay, so that's all you need to know for solution stoichiometry. I know actually it's a lot, but we'll have lots of questions, lots of quizzes, lots of examples and practice at class, and look forward to seeing you there.